Okay, so let's go ahead and work on these last two problems, which I wasn't able to get to from before. So let's we scratched these out on the previous page. And just a reminder, on the previous example problem, you should have had an answer of x equals 2. 47 was also a solution, but it turned out to be extraneous. Alright, moving on to problem number 4. Square root of x plus 7 minus the square root of x minus 1 equals 2. We're going to solve this the same way. We're going to isolate a radical, square both sides, simplify, isolate the radical again, square both sides, and solve. So here's my first step. Let me change colors, go blue, and I get square root of x plus 7 equals 2 plus the square root of x minus 1. I now have this isolated, so I'm going to square both sides, change colors to show that. Square, square. This simply becomes x plus 7, and on this side I get 4 plus 4 times the square root of x minus 1 plus x minus 1. Now I'm going to go ahead and combine some like terms, and so I get x plus 7 equals 3 plus 4 square root of x minus 1 plus x. Go ahead and show isolating of the radical. This is the only radical I have. I'm going to try and get this all alone. So I'm going to subtract 3. I'm going to subtract x. But what I do to one side, I must do to the other. Scroll down. And so now I'm left with x minus x is 0, 7 minus 3 is 4, equals, these canceled, 4 square root of x minus 1, and these canceled. Alright, so now this looks pretty nice. Divide both sides by 4. Okay, so divided by 4, divided by 4, 4 divided by 4 is 1, equals 4 divided by 4 is 1, times the square root of x minus 1. Now my radical is isolated. I'll go ahead and square both sides. 1 squared is 1. Square root of x minus 1 squared is x minus 1. Add 1 to both sides, and I get x equals 2. Now before I go ahead and box that as my final answer, I'm going to go ahead and check and see if it is an extraneous solution. So here's my check. I'm wondering, is the square root of 2 plus 7 minus the square root of 2 minus 1, is that actually 2? That's my question, which is why I put a question mark there. Let's see, the square root of 9 minus the square root of 1, is that equal to 2? Is 3 minus 1 equal to 2? Check. My answer is 2. Box it and be ready to move on to the next problem. Alright, good stuff, good stuff. These are still notes. You'll try your own in just a few minutes. Alright, moving on. Here we got problem number 5. Problem number 5. Ooh, we got a cubed root and a sixth root. This is tricky. Okay, a cubed root and a sixth root. So what we're going to try and do here is we're going to try and raise each of these isolated radical expressions to the same power so that I get rid of the radicals. A simple way to think about it is when you look at the number 3 and you look at the number 6, what's their least common multiple? 3, 6, 9, 6, 12, there we found it already, 6. Least common multiple is 6, so that's what we're going to raise both sides to. You might be wondering why or how. Well, anything I do to one side I can do to the other. This was the beginning of our notes from the other day, and now look what happens. I get 2x minus 1 to the 6 over 3 equals x plus 1 to the 6 over 6. 2x minus 1, 6 over 3 is 2, x plus 1 to the first power. So now this is just a basic algebraic equation. Let me square the binomial 2x minus 1, and when I do I get 4x squared minus 4x plus 1 equals x plus 1, and now we just have algebra. We have a quadratic equation, so I'm going to try and move everything over to this side, and when I get it there, look to see if it factors. If not, quadratic formula or completing the square. Try working on this problem, coming down to the solution, check for extraneous solutions, and then consult back with me and see if we got the same answer. So put me on pause and try it on your own. Okay, so here's my work from where we left off. I subtracted x, I subtracted 1, and what was nice is my constant term fell out. So I just had two terms and they had a common factor, so I factored that out. And now I used the zero product property, either x equals 0 or 4x minus 5 equals 0. I tested 0 all the way over here, and it turns out that 0 doesn't work. Cubed root of negative 1 is negative 1, sixth root of 1 is 1, those don't equal each other, so 0 got eliminated. And when I tried 5/4, it was really hard to see whether or not this was true. Is the cubed root of 3/2 equal to the sixth root of 9/4? So I got a little creative, still asking the same question here, but now instead of cubed root I wrote it as 1/3, instead of sixth root I wrote it as 1/6. And then I thought of 9/4. I knew 9 over 4 had a relationship to 3 over 2, so here I wrote it as and this really should be in its own separate parentheses. So 3/2 squared is 9/4 to the 1/6, and so you can see that 3/2 squared to the 1/6 is the same thing as 3/2 to the 2/6 power. And so it's the same. Check, 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 check. Alright, good work up to this point. That's a higher level problem, but you may remember the main concept is finding the least common multiple of the roots and then raising each side to that number. If you just keep that in mind, they should be pretty straightforward. Alright, so here's some in-class notes that you should still be taking for this part of the lesson. Solve each of the following for the given variable. Here we have the cubed root of x minus 2 equals 0. To solve, I'm going to try to isolate the radical. I need to get this all by itself on one side, so I'm going to add 2 and then cube both sides. So I end up with the cubed root of x equals 2. Cube both sides, x equals 2 cubed, x equals 8. Let me check. Is the cubed root of 8 minus 2 equal to 0? 2 minus 2 equals 0. Check. Alright, good. Over here on problem number 2, here's my radical expression. Let me try to isolate it. I'm going to add 1 and then divide by 3. So I get the square root of x plus 4 equals, see, I added 1, that made it 9. I divided by 3, that makes it 3. Square both sides, x plus 4 equals 9. Subtract 4, x equals 5. Let me check my work over here. Is 3 times the square root of 5 plus 4 minus 1 equal to 8? Is that true? Is 3 times the square root of 9 minus 1 equal to 8? Check. I can see that it works. Beautiful. Alright, not so bad, huh? Now we get two radicals. Isolate the radical. Bring it over to the side. Square both sides. Get rid of the radicals. Then you have an algebraic equation. Solve for x. Check for extraneous solutions. Give it a try. Come check back with me in a few minutes. Okay, here we go. This is what you should have had. Square both sides. Get rid of the radicals. Simple algebraic equation. Plug 1 back in. And you see the square root of 2 minus the square root of 2 does in fact equal 0. So x equals 1 is our solution. Let's go ahead and try it over here on this side. The radical is already isolated. See if you know what to do. Check back with me when you're done. Okay. Square both sides. X squared is x squared. We're squaring a radical. Gets rid of the radical, so equals x plus 6. Go ahead and you have a quadratic, so let's get everything equal to 0. Factor. It is factorable, so I factor it. I get my two solutions. I check my two solutions. X equals 3 works. However, when I plugged in negative 2, that did not work. So not completely correct on negative 2, but I do feel fairly confident in my x equals 3. So boom, bam, there's my solution. Alright, a couple more. Square both sides. See how it goes. Check with me in a couple minutes. And x equals 1, and it checks. Alright, number 6, challenge problem. Go for it. See you in a couple. Alright, and once again we get x equals 1, and it checks, so I think we're good. You're going to go ahead and try the book assignment from 7.6 day 2, and I believe we will be having our exam on Thursday, in case there's anybody who might be missing Friday. I can't imagine anybody would, but just in case, we'll have our test on Friday. If you have any questions, feel free to ask me in class. Talk to you later. See you then.